Okay guys, welcome to my library. I'm going to try to videotape this and show you those color labs that we've been discussing. I am in a little bit of a hindered position because this looks much better in real life than it does on camera. I'm hoping that the ISO and the logistics on the camera work out. If they don't, I am sorry. You might just have to trust me until we see each other again. So here's what we're working with today. So this is it's also my library slash guest bedroom, just FYI. I've got these little dudes. These are light cannons, and basically all they are flashlights that have the ability to have the filters changed in them. Um, so the first thing we need to do in order to get this to work is I am going to have to turn off the lights in order to get this to go down. So Alexa, turn off the library. There we go. All right, so now it's dark in here. I am first going to try to show you what a complementary color is. So a complementary color is a color that adds together to make white. So red, green, and blue are the colors that make white. So if I have green, let me see if I get this to focus. If I have green and I have magenta, green and magenta, here are your two colors, green and magenta. Now, those are green, obviously composed of green, magenta, composed of red and blue. So when I overlap them, you should see that it makes white. It's not perfect, but it's a pretty close approximation. Another complementary color would be red and cyan. So I'm going to pull those up real quick. I've got cyan, and I've got red. Now, I am out one color. I don't have blue, so you'll have to bear with me on the last one. So red is obviously composed of red. Cyan is composed of blue and green. And when I overlap them, we get white. I couldn't quite get to the school fast enough. I got to the school right as they were closing up for the shutdown. And so I did not get the blue, unfortunately, so I'm out of blue. But we should be able to demonstrate these using the colors that I have. So the complementary color for blue would, of course, be yellow and I can't talk. Yellow and blue would be the complementary colors that we didn't go over. So you've got cyan and red, you've got green and magenta, and you've got yellow and blue. Unfortunately, I can't show you yellow and blue because I am out right now of the blue filter. Now, over here, against the wall, there we go, I've got some of the basically just got some shirts. I've got an orange shirt, a burnt orange shirt, a red shirt, a yellow shirt, a gray shirt, a dark gray shirt, and a blue shirt. I've also got a green shirt there, but it really didn't turn out to be the color I thought it was. I think it's too gray to really show up for this demonstration. So those are the colors that we're working with. What I'm going to do first is I am going to take a red light and shine it on these shirts. Now, if we have these things correct, the orange shirt should only be able to reflect the color orange, which is really red and yellow. So same thing with the burnt orange shirt. Red should only be able to reflect the color red if it's there. The blue shirt should only be able to reflect the color blue if it's present. All right. I've also got a lemon and a apple here that we can look at as well. So to start with, let's look at red. So when I shine the red light onto the orange shirt, it sure enough looks red. And as I come around to the yellow shirt, the burnt orange shirt, it looks red as well. And as I keep on coming around to the red shirt and the yellow shirt, all of those are able to reflect red because they have red in them. But whenever I shine it down here on the blue shirt, you should notice a distinct drop in the amount of color that's reflected. Again, look how much red is being reflected back from these that can reflect the color red. And then when we get to this blue shirt, blue can only reflect blue. And so for the most part, it turns to looking like it is black. It really helps to compare it to the gray shirt that we were looking at over here. And notice that the gray shirt and the blue shirt take on a very similar hue underneath the red light. All right, so now I'm going to try a different color. So I'm going to switch this out, and we're going to go to the color green. So green reflects, or sorry, green is the only color that's being shown here. So anything that doesn't have green in it won't be able to show a color. So for example, the orange shirt over there is made up of red and yellow. Yellow has red and green, so it should be able to show a color. So the the oranges and the yellows should be able to show, but the rest of these probably won't. So the blue shirt should look gray, the red shirt should look gray, obviously the gray shirt should look gray. So let's take a look. So the orange shirt, sure enough, looks like it can reflect some color. Maybe even looks a little orange. I think there's some white light still getting through. All right. Burnt orange shirt looks a little bit grayer, but definitely still getting some green kicking through. The yellow shirt definitely looks like it's got some green. But notice that the red shirt, you don't see any red coming through. It's only the green that you can kind of vaguely tell is being reflected back. And notice that the color of the red shirt is very similar to the color of my gray shirt over here. So the red and the gray have a very similar hue, as does the blue shirt, because there's no blue light to be reflected back. We only have green light present. Okay? So whenever green light is shining on red or blue, since those can only reflect red and blue, they look black. By the way, let's take a look at that apple. That apple, underneath blue light, underneath green light, looks awfully black. It's hard to even tell that there's any red there at all. All right? The lemon, on the other hand, whoa, it brightens up the screen because it's able to reflect a ton of that green light. All right? Again, I can't show you blue, so I'm going to have to show you. Let's go with cyan. Let's see if we can get some cyan out. Now, cyan is composed of the colors blue and green. And so whenever I take the cyan light, anything that's got blue or green in it should be able to be seen. Those orange shirts, remember, they have a little bit of yellow in them. And so whenever I shine them on here, you should still be able to see them. You notice how that looks a little bit green tinted. If it doesn't look like it to you, I promise it looks like it in real life. And then as I move over to the red, notice that this shirt right here that looks a little blue, that is, that shirt that looks a little bit blue here is our red shirt. So that's a red shirt. It's not blue, all right? But it looks a little bit gray under this light, just like our gray shirt looks. So look at the hue of that gray shirt. Look at the hue of our red shirt. It's not able to reflect that red. The yellow shirt there is looking awfully green because there is green light here to be reflected back, but no red. All right. Now that blue shirt is able to reflect pretty much all of its blue, and that green shirt that I had over here looks awfully green. All right, because cyan is made up of blue and green, and so anything that's got blue and green in it should be able to be reflected. So the blue shirt gets blue, green shirt gets green, yellows look green, but the red just does not show up at all. All right. Let's see what it does to the fruit. So the apple should still be black because there's no green or blue in an apple to be reflected, and the lemon should look green because there's no red to be reflected. So let's see, does that look accurate? The lemon looks a little bit more tennis ball-y. So let me see if we can get this brightness down a little bit so you can see it a little better. All right, so the apple is definitely black, but the lemon looks a little bit more like a tennis ball color. Isn't that weird though? Look at that apple looking all black. All right. So if you wanted to shine a color onto the lemon to make it look black, like the apple, you would have to use blue, because blue is the only thing that doesn't have doesn't have the color in it. Or sorry, it doesn't have the red or green color in it. Alexa, turn on the lights.
Sorry, I didn't find a device named lights.
Of course it didn't. Alexa, turn on the library. There we go. Technology is dumb sometimes. Okay, so the final thing that I want to say here is, first of all, if you could not see this, it's my fault, not yours. All right? Second of all, if you want to know, I really do apologize for not having a blue. I feel a little bit like I should have had that. But the final thing I want to close with is basically when you're trying to figure out what colors are going to be reflected, look at what color it is. If it's red, it's going to reflect red. Blue is going to reflect blue. But if it's not a blue, red, or green, you got to think about what color it is made up of. So yellow, for example, is made up of the colors red and green. And so as long as there is red or green in the light you're shining on it, you should be able to see it. It won't look gray. But if the color that is being reflected by the shirt is not present in the light that is being put on it, then it will look gray or black. All right? So the final thing to close with is, if you want to make a red apple look black, since it reflects red, you can shine any of the three colors, cyan, because it's made up of blue and green, or blue and green on it. If you shine cyan, blue, or green onto a red apple, it will look black because there's no light to be reflected. And if you want to make a yellow lemon look black or a yellow banana look black, yellow is reflecting back the colors red and green. And so the only color you could shine on it to make it look black is blue, which I do not have a filter for. And I apologize for that. All right, but a yellow banana, if you want to make it look black, you have to shine blue on it, or a yellow lemon, you need to shine blue on it. All right, so this is me signing off. I hope y'all were able to see this. If you were not, I apologize, and I guess go deer.